Hello everyone, this is Mr. Fawcett, and we are back for part 3, which will be our final part of our conditional statements lesson. I have some new vocab to introduce, so we're going to go down until we hit that. And in the first two parts of this lesson, we only talked about conditional statements. Now, there's some other types of statements that are similar to conditionals, but we end up rearranging parts of the conditional statement. So our conditional statement's made up of a hypothesis and a conclusion. Right? If we, I'm just going to write out what a conditional is here so we can see it. Conditional statement. It's going to be an if-then statement. And it's going to be a P implies Q, where P is our hypothesis and Q is our conclusion. But we have other names for statements that are made up of the hypothesis and the conclusion, but just in different orders. And maybe we're going to talk about this idea of negation as well. So the converse. The converse of a conditional statement is written by switching the hypothesis and the conclusion. So we can look at an example. We're back with Jasmine and her basketball game. So the conditional statement would be, if Jasmine wins her basketball game, then her family will go out for dinner. That would be the regular conditional statement. The converse would just be switching the hypothesis and the conclusion. So if her family goes out for dinner, then Jasmine won her basketball game. Symbol-wise, we just switch the Q and the P. Okay, the inverse. This is where we get to the concept of negation. So the inverse of a conditional statement is written by negating the hypothesis and the conclusion. Negating just means saying something will not happen. So in this case, we use a little squiggly sign. So not P implies not Q. That's how it's read. Okay, so we're starting with our conditional, right? And all we're doing is negating the hypothesis and the conclusion. And let's look at what this negation thing means in words. So the conditional, again, we can start with that. If Jasmine wins her basketball game, then her family will go out for dinner. Negating means saying the opposite. So if Jasmine does not win her basketball game, then her family will not go out for dinner. So all we said was the opposite of the hypothesis and the conclusion, but we kept them in the same parts. Okay, let's look at the contrapositive. So the contrapositive of a conditional statement is written by switching and negating both hypothesis and the conclusion. So it's a mix of the converse and the inverse. Symbols wise, we have not Q will imply not P. So again, we have our conditional here, and then our contrapositive. If her family does not go out for dinner, then Jasmine did not win her basketball game. So again, we negate the hypothesis and the conclusion and switch them. What you're going to do is practice writing these different types of statements. So I give you an original statement, and then you need to write the converse, the inverse, and the contrapositive. Then you're also going to talk about whether they are true or false. Remember what makes a statement true or false. Okay, a statement is only false if the hypothesis is true and the conclusion is false. That's the only time. So if that never happens, the statement is always true. Okay, take some time to work through these on your own, and then we'll come back and discuss. Okay, so I just typed in our converse, inverse, and contrapositive. Now we need to determine the truth value of all four of these. So the original conditional said if a number is divisible by 10, then it is divisible by 5. So again, we only have to think about, is there ever a time where there's a number divisible by 10 but not divisible by 5? Because that would be the only time that the entire statement is false. And there is no number like that, right? If a number is divisible by 10, then it is always divisible by 5. So this truth value is true. The converse says, if a number is divisible by 5, then it is divisible by 10. Well, the converse here is going to be false because there are plenty of numbers, and we could just pick 25. So 25 would make our hypothesis true. It's divisible by 5. But it would make our conclusion false because 25 is not divisible by 10. So the converse here is false. The inverse says if a number is not divisible by 10, then it is not divisible by 5. So is there a number that's not divisible by 10, but is divisible by 5, right? And again, of course there is. We can use 25 again. 25 makes our hypothesis true because 25 is not divisible by 10, but it makes our conclusion false because it is divisible by 5. So again, we found a spot where our hypothesis is true, our conclusion is false, which makes the entire statement false. I know it gets a little tricky when you throw in the nots here, when you use the negation for the inverse and the contrapositive. But again, if you think through it, and you can even write down these examples if you need to keep your thoughts organized. So the contrapositive says if a number is not divisible by 5, then it is not divisible by 10. So is there any number that is not divisible by 5, but it is divisible by 10? And again, you could try a bunch of examples, but no, there is no number that makes our hypothesis true and our conclusion false. So the entire statement is true. So the question below says, which statements had the same truth value? Well, our original and contrapositive had the same truth value. Those were both true. And our inverse and converse had the same truth values. Those were both false. So when related conditional statements have the same truth value, we deem them logically equivalent statements. Logically equivalent, meaning they just have the same truth value. The original statement and the contrapositive will always have the same truth value. Notice that this does not mean that they will always both be true. They could also always both be false. They're just going to have the same truth value. So if one's true, the other one's true. If one's false, the other one's false. And the converse and the inverse will always have the same truth value as well. Again, this does not mean that all four of them couldn't have the same truth value. So all four of them could be true. They could all be false. We just have to make sure that the contrapositive and the original have the same truth value, and the inverse and the converse have the same truth value. Again, that's what I'm just saying down here, because it depends what statement we start with. If that one's true, then there's a chance for all of them to be true. If it's false, well, then there's a chance for all of them to be false, but maybe some of them would be true. Okay, let's do some examples. So I give you an original statement. You're going to come up with the three other statements. Then you're going to come up with your own conditional statement, your own original statement. And this one could be false, it could be true. But regardless, you're going to come up with the other three as well and put their truth values down. So take a chance to do that, and I will review both of these when you come back. Okay, so our original statement was, if the measurement of an angle is 50 degrees, then it is an acute angle. So again, to check and see if it's false, is there any time when a angle is 50 degrees, but it is not an acute angle. And no, if an angle is 50 degrees, it is always an acute angle. This statement is true. The converse says if an angle is acute, then its measurement is 50. Well, this is clearly false because I can have an acute angle, but its measurement does not have to be 50. It could be 30. There's our counterexample. So false. The inverse, if the measurement of an angle is not 50 degrees, then it is not an acute angle. Again, this is going to be false too, because my hypothesis could be true. I could have an angle that has a measurement of 30 degrees, which is not 50, so it makes the hypothesis true. But it would be an acute angle, right? So we could have an angle measurement that's not 50, but it could still be acute. So false again for our inverse. And our contrapositive, if an angle is not acute, then its measurement is not 50 degrees. Well, if an angle is not acute, is there any chance that its measurement is 50? And no, right? If an angle is not acute, its measurement is going to be something other than 0 to 90 degrees. So if the angle is not acute, its measurement is never going to be 50 degrees, which makes this statement true. So notice that our original and the contrapositive had the same truth value, as did the inverse and the converse. So everything checks out as it should. Okay, let's go to the one that I came up with. So I said, if you want to be a doctor, then you will go to college. So college is a requirement to be a doctor, right? You can't be a doctor, or at least a practicing legitimate doctor in the United States, if you do not go to college. I'm assuming we're in the United States, you're not going somewhere where they just let anyone be a doctor. So this is true, right? It's not possible to want to be a doctor but not go to college. Or sorry, it's not possible to want to, yes, it's not possible to want to be a doctor but not go to college. The converse, if you go to college, then you want to be a doctor. Well, this isn't true, because you could want to go to college, but you could want to be something else. You could want to be an engineer. You could want to be a biologist. You could want to be a mathematician, right? You could want to be a teacher. So this is false. The inverse, if you do not want to be a doctor, then you will not go to college. Well, if you don't want to be a doctor, so let's say you want to be an engineer, that means you're going to go to college for the most part. So again, this is false, because there's an example where our hypothesis is true, but the conclusion ends up being false, right? If you want to be an engineer, then you are going to go to college. And the contrapositive, if you do not go to college, then you will not want to be a doctor. Well, this is true, right? Because if you do not go to college, then you can't become a doctor, right? So we can't have a true hypothesis of not going to college and a false conclusion of becoming a doctor. Thus, this statement is true, and we can see the same truth values for the original, the contrapositive, and the converse and the inverse. So I know this lesson was kind of long, and I know it's a different type of math. It may be frustrating at first because it's not something you're used to. You may prefer just coming in and solving equations, figuring out diagrams, etc. But it is good to branch out and to get your brain to think about different types of problems than what quote-unquote the standard may be. So I look forward to seeing you next video. Until then, as always, enjoy the rest of your day.